So this video is from 2016. It's question number 3. I've classified it as interpreting graphs because we're given a graph here and we need to interpret it as it relates to the function. This is one of the cases where we have a integral defined function, and anytime we have an integral defined function, there's some value to taking the derivative up front. Using the fundamental theorem of calculus, we know that g prime and
we could also say g prime prime of x is the same thing as f prime of x. And that's going to save us when it comes to justifying later on. Furthermore, we could even start taking a look at the various regions and break this down into several triangles that have areas of 4 square units, because they're 2 by 4 triangles. So I don't know if we'll need that yet, but it's useful to have that information up front. Part A says, does G have a relative minimum, max, or neither at x equals 10? So, a relative or local minimum occurs where G prime of x, which is the same thing as f, changes from negative to positive. In other words, G is going from decreasing to increasing, therefore G prime is going negative to positive. When we look at the graph here, this is a graph of G prime, or f. This occurs only at one location. This occurs at x equals negative 2. Okay? A relative max, and again, I'm writing more than is required for the problem because they only care about at 10. A relative max would be where it goes from positive to negative. They want us to focus on specifically at 10. So, to answer their question, at x equals 10, there was no sign change. The sign of g prime of x does not change. Therefore, there exists no max or min at x equals 10. Okay, the point breakdown for part A is you get 1 point for an answer with justification. And my answer was no max or min because the sign of g prime of x does not change. So 1 point for part A. Let's look at part B. Part B says, does the graph of G have a point of inflection at x equals 4? So a point of inflection occurs when G prime prime of x changes signs. Another way of saying G prime prime is changing signs would be like saying f prime of x changes signs, because G prime prime and f prime are the same thing. And another way of saying f prime of x changes signs would be saying f of x changes increasing to decreasing, or vice versa. At x equals 4, f is changing from increasing to decreasing. So at x equals 4, f of x changes increasing to decreasing. Therefore, g of x has a POI at x equals 4, or the graph of g of x has a point of inflection. This one is worth 1 point. 1 point for an answer with a justification. Yes, it does have a point of inflection at x equals 4 because f prime changes increasing to decreasing. Find the absolute minimum value and the absolute maximum value for G. So this is a question about absolute extrema, and absolute extrema will always occur at the endpoints
or critical values. So we're going to be looking for our endpoints and our critical values. So the question that exists is, what is g of our endpoint, g of our other endpoint, and then do we have any critical values? And in this case, we have several critical values. A critical value is where g prime equals 0. So we have one here, 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 and here. But the only one where the sign changes is at -2 and 6. So we really only need to choose to evaluate g of -2 and g of -6. You can take the extra time to evaluate the other ones, but we know they're not extrema because g goes from increasing behavior to increasing behavior. So this will not be a maximum. When we evaluate g of -4, that's saying what is the integral from 2 to -4 of the function expressed in the graph. So 2 to -4, we are going to lose 8 units and then gain 4 units. So lose 8, gain 4 gives us a value of -4. If we do the same thing for g of 12, we gain 8, we lose 8, and then we lose another 4. So g of 12 is also -4. Testing the critical value at -2, we lose 8 units. So this is -8. And then at 6, starting at 2, we gain 8 units. Okay? And this is relative to whatever our initial condition was. Actually, it looks like this starts at 2, so these account for that. The maximum value, absolute max of 8 at x equals -6. Absolute min of -8 at x equals -2. And this really should have been a +6, so I don't know why I wrote -6. That's, oops. Okay, sometimes we make mistakes. Hopefully you go back and correct them while you're taking the test, or don't make them. That's part C. The grading for part C, there's going to be 4 points that come out of part C. The first point comes from, did you consider those 2 critical values? The second point comes from, did you consider the endpoints? And then you get 2 points for the answer with justification. And I think by running the candidates test, that's a justification by the candidates test.
Well, boy, how many candidates would pass a calculus test?
And finally, let's look at part D. Part D is asking us for where g of x is less than or equal to 0. And we should recall that g of x is the accumulation from 2 to an x value of the function expressed in the graph. So if I were to evaluate g of 2, that would be the same as saying what is the area enclosed between x equals 2 and x equals 2 for the function, which is obviously 0 because you've enclosed no area. So starting at 2, the value of g is 0. So I'm just going to put numbers down here to represent that value. If I were to continue this trend and say, well, what is g of 4? I'm asking the question, how much do I accumulate from 2 to 4 of the function f of t? And so the graph is positive, so I'm accumulating positive area all the way up to a value of 4 square units. Okay? And we can continue that trend, g of 6, so I'll put that value at 4. If I go all the way up to g of 6, I get a value of, we've added another 4 units, so a value of 8. Continuing to move forward, from 6 to 8, I lose 4, and then 8 to 10, I lose another 4. So finally at g of 10, I have both gained my 4 units of accumulation and lost 8 units of accumulation, for a total accumulation of 0. Then from 10 to 12, I am losing accumulation up to 4 units. So that all has negative answers. So g of x is less than or equal to 0 on the interval of 10 to 12. Actually, since it's equals 0, we're going to include the endpoints, 10 to 12. That's moving forward. If we move backwards, starting at 0, and we work backwards and above is a loss of accumulation. So at this point, when I get to g of 0, again, I'm saying what is the accumulation from 2 to 0 of the function? That would be a loss of 4 units. So we lose 4 units. Keep losing them down to g of negative 2. We've lost another 4 units. So that's at negative 8. And then if we keep going backwards, we start gaining because we are working backwards and below, so that's a gain of accumulation to a value of, well, negative 8 plus 4 units would be back to negative 4. But over this entire interval, our g of x winds up being negative because we lost a bunch and only gained back a little. So that interval runs from negative 4 to 2. The point breakdown for this part is that there is 2 points for the intervals. So they don't really ask for the justification. I suspect they would give you 1 point for each interval. And then finally, the last and final point is expressed here somewhere in the problem. You write the equation or the answer g prime of x equals f of x. So we have to mention that relationship. And that's just good habit anytime you have an integral defined function. All right, thanks for watching. Be sure to smash that like button, comment, subscribe. Have a good day.